So now all the stuff we've been working on has gotten to the point now where we're going to be able to solve these types of equations. We're going to be solving equations where we have our variables as exponents. And logarithms, again, remember, logarithms are nothing but reworded exponents. They're just weird exponents. So logarithms are going to allow us to solve these types of equations by using all of the different properties that we've had so far. For example, if I'm looking at these two problems, in order to be able to solve for the variable, what we have to first be able to do is get a common base. So if I'm looking at a 4 and I'm looking at an 8, how can I turn either one of them into having the same base?
Multiply the 4 by 2.
I want to use them as a base 2. Okay? I can rewrite 4 as a base 2 by having what as its exponent? 2. Good. So I rewrite this as 2 to the 2 times 3x. I do the same thing on the other side. How do I rewrite 8 as a base 2?
Wait, what?
To the 8 cubed, 2 cubed.
Oh, okay.
What I'm doing here is I'm trying to get the base to be the same on both sides of the equation. By doing that, I am now able to use some of the properties of logarithms that we've been working on. The property that we're about to use is this. What is the log base b of b to the x equal to? X. Because what happens? The b's drop. Notice how I have got the same, and I have the same base with the logarithm as I do with the base that has the exponent. The exponent comes down. What is the other rule about working with equations? When you do something to one side, what do you have to do to the other? It's the exact same thing. So, since I have a base 2 on both sides, I'm going to log both sides. Yeah.
Oh, yeah.
By doing log base 2 on this side, and a log base 2 here, have I kept the equations equal by doing log on both sides? What happens to the exponents?
Drop out. Or drop, not drop. Oh, no.
I hope we can all solve that equation. Again, notice all we had to do here was create the same base on both sides of the equation. We log of that base, we drop, and there you go. You get 3x is equal to 3. What's x?
1.
Very good. Now, what would you do to check your work?
Calculate it back.
Yeah, you substitute back in with your calculator. In this case here, all you have to do is just raise the exponents to the values, which is not going to be a very difficult thing to do. Okay? Again, let's look at another one. The idea here is that we want to create this common base. I'm going to create the common base here. The bases that you're going to be working with, ladies and gentlemen, you're going to be able to notice right away which one they're trying to get you to go here. What base am I going to work with here? 3 is good. So if I have 9 to the 2x and 3 to the x minus 6, my common base is going to be a base 3. So how do I rewrite 9 in terms of a base 3?
3, 2.
3 squared, good. So when I rewrite this as 3 squared, I get 3 to the 2 times 2x is equal to 3 times to the x minus 6. What log base do I have to do to both sides? Base 3, right? And what happens to my exponents?
Drop.
They fall miraculously from the sky. I get 4x is x minus 6. This really isn't that scary, is it?
Yeah, more scary than scary. X equals opposite of 2.
We get x equals -2. No.
I heard
There's about 3 or 4 different methods of these types of equations. We're probably going to only get through the first 2 today. Okay. That's one of them.
Are we done now?
Yes.
Mark, it says log roll.
I know, because we're rolling right along.
That's funny, bro. That was funny.
That was bad.
Yeah, I didn't think it was
Pretty good.
All right.
funny because it wasn't.
Now I have 2 to the x equals 7. Again, that's asking us 2 to what power is going to equal 7?
Who knows?
Who knows, exactly. Now, what's 2 squared?
4.
What's 2 cubed? 8. So 2 to the something that's going to equal 7 is going to be bigger than 2 but smaller than 3, right?
Right.
How do we figure that out? Well, again, in order for me to get that exponent to drop from the superscript, what would I have to take the log base of on the left-hand side? Log base 2. What would I have to do to the other side then? All right. So what happens now is I take the log base 2 of this side and the log base 2 over here. My left side gives me x equals the log base 2 of 7. Which means we need to know how to calculate that. There is an extremely easy formula for doing this. It's called change of base. The change of base formula for whenever you have a non-base 10 problem always looks like this. Log of whatever that number is divided by the log of the base. And that's your answer.
Oh, that's all you gotta do.
Yeah, because what it's doing, it's converting, because your calculator runs base 10, it's converting it into a base 10 to give you the answer. Yeah.
Can we go back to the last one real quick? How do you get x is equal to negative 2?
Probably distributed. Okay. One other thing here. There you go. You did divide out all terms. All right. In this case, yes, sir.
So then does this just become log of 7 over 2?
No.
You have to keep both logs that
Correct. What happens here, and this is a good question, when you type this in your calculator, you have, when you hit the log button, what opens up? Which means what do you have to close? You just have to close it and divide it by the log of 2. You just have to close those parentheses, and that'll give you your answer. 2.81. You round everything to 2 decimal places, please. Okay? So x is going to give you 2.81. Now, what if I told you there's another way to type that in your calculator?
I found it.
I would say
I
you might be right.
found it.
What's up?
I found out the calculator.
I don't know. And this one here, if I had 5 to the x equals 8, I'm going to solve that one. I'll show you the other method of typing in your calculator. What do I have to do to the log on both sides here?
Divide it.
By base what? I got to do a log base 5. So if I write this out, I get x is going to equal log base 5 of 8. That'll give me my value of x. Now, in your calculator, there's another way to type that in. You type in alpha window, number 5. And look what it's asking you to put in. Holy guacamole is right.
Fuck is that, man?
That's a good one.
Okay? You can type it in that way as well. And you get log base 5, hit the arrow button over, put in the 8, and hit enter. Either way, whether you use that method or that change of base method, you're going to get the same result.
Try that method.
You can also just hit math, alpha math.
Yeah, that works too. There's a couple ways to get to it.
What do you have to hit again, Mark?
Alpha window.
He's sitting on it. Jack is sitting on my
Why are you sitting? Were you trying to hatch an egg?
Oh, because you're trying to hatch a math.
Okay.
He's sitting on it.
One last one.
Hey, that's all. Hey, I'm gonna do it right now. Feel my calculator.
Yes. You suck. Sometimes I can't even do this one straight.
He's punching
Not
his
in here.
calculator.
Yeah, it's not in here. It's not in
Michael,
here.
it's not in here.
Is there a mole in here?
Do you think I know what a mole is?
Michael, it's in this. Michael, how was that humanities quiz?
Anyway, in this case here, treat it like you would a normal 2 or 3 step equation.
It's in Miss Favor's room.
What would you have to do first?
Might as well subtract.
I agree with you, Jack. Again, guys, treat it like you would a normal two-step, three-step equation. Subtract 4, you get 10 to 2x minus 3 is 17. What log base would you have to do to get that exponent to drop now? Now, it's log base 10, so what could I just use? Log. So 2x minus 3 is going to equal the log of 17. Now, again, the log of 17 is just going to be some crummy decimal. I still need to solve for x, so what do I have to do to move the rest of the stuff over?
Add 3 divided by 2.
Add 3 and divide by 2. I know that my final result is going to be x is going to equal log of 17 plus 3 all over 2. What do I have to be very cautious about when I type that numerator in? My parentheses. I will recommend when you have a fractional log like this where you have to work with it, use your alpha y equals button on your calculator. Oops, not the math. Yeah, go to your alpha y equals, type it in directly like that. Log of 17. Make sure you close your parentheses. Add the 3, go to the denominator, hit a 2, and hit enter. 216. 212. Sorry, I was looking at the third one. Sorry about that. What's that?
The eyes have
I thought it would.
The nails have eyes.
I was trying to play a joke with the hearing.
The dog snorkel.
Wait, I don't get it. What was that joke even? What was the joke?
Yeah, 3rd grade.
What did you say?
Are we okay on these? Let me give you a handful. Let me give you a handful of these to start with for tonight. So this is section, what is this, 8-6, I think. Like I said, there's gonna be a little bit more to this tomorrow. We'll make it a little bit weirder. Don't forget, you could get no solution. You could have extraneous solutions. Check your answers, okay? Do those for tonight, please.
Draco always trying to say other people.
Do you know what it was? It's pretty mad.
Is it like 2.8 something?
22 times 10 to the 23rd.
Whatever.
It's pretty much mad though. I mean,
Yes, sir.
Jack said that you're most likely from